Hi everybody, welcome back to class today. For this Friday's lesson, what we're going to be working on is mass. And mass is one part of something we call matter. And this is where we're going to be starting into the actual physical science concepts of this class. Physical science is the study of matter. So we're beginning to look into that physical science concepts now. So just a real quick introduction to matter. And you're going to see this term come up again and again throughout this year. But matter, when you think of matter, some people have misconceptions with it. Some people think about it as all the stuff that exists in the universe. And I've also heard people say that everything is made of matter. Some people will think that everything out there, that everything that you can think of is matter. And the closer definition is when people actually say stuff. Now that is not correct, but it is closer. The actual definition of matter is anything that has mass and volume. And these are the two topics, the two concepts that we're going over in this physical science section. And in this note section, we're going to be starting with mass. And the reason we're going over mass and the reason I have this triple beam balance here, this picture, is because this is how we measure mass. And with mass, we're looking at the stuff inside of something. When you see this cube, you've probably seen it in math class, you might think length times width times height. And the reason we have that is the equation for volume. So that length times width times height is why we have this cube here. Now getting back to matter. To be able to study matter, we have to know what matter is. And again, we said anything that has mass and volume. But because you're just learning about this, you've got to think about what does that actually mean. A simple way to think about it is anything that you can see, you can touch and interact with would be matter. So I always ask, do you think that air, the air around you that you breathe, do you think it is matter? Take a second to think about that. Would air be matter? A way you can try to check this is right now, put your hand up and start waving it back and forth in front of you real fast. What do you feel? You feel the wind moving between your fingers. You feel the palm of your hand and the back of your hand hitting against the air. You can feel something. You're interacting with something. Air is matter. It has mass. You might not think that it's much, but when we get to it later this year, you're going to see just how much mass air has, or at least the air that's above you. Another way you can think about this is go to your light switch right now. Turn your lights off and then turn them back on. Do you feel like anything just hit your body? Something just smacked you upside the head? Something just hit you in the arm? Something just hit you in the chest? No. Every time you turn those lights on and off, you don't feel anything. The reason is light is energy. And energy, all forms of energy, are not matter. Air is matter. You can interact with it. Because if there's a really windy day, you see people leaning into the wind sometimes. If there was no wind there to lean into, you'd see people falling flat on their face all over the place. Everybody might chuckle a little, but that would mean there's no matter there at all. But you see people, again, the wind pushing them back, them leaning into it. They have to be leaning into something. But energy, like light, is not matter. Every time you turn on that light switch, you don't feel something smacking you each time. It would be really weird walking down the hall and you keep feeling like something's hitting you across the head, hitting you across your back, hitting you in the stomach every single second because of light hitting you. That would be really annoying. Sound is not matter. Sound is energy. The reason you think you can hear sound like the thumping of a bass when it's hitting you in the chest again and again is because you're feeling the air hit you, not the sound. The sound moves the air. The energy is making air move, and the air is what's hitting you, not the sound itself. The same with a campfire. The heat, you can feel the heat, but you can't interact with it. You can feel an energy transfer occurring with the heat. We'll study more about that later this year. But you can't scoop up heat. You can't hold heat. You can't interact with it. You can't really touch it. Yes, you can feel it, but you can't touch it. It's an energy transfer that's occurring. So that's just a real quick introduction into matter. Now, one of the pieces with matter is mass. And mass is the measure of the amount of matter in a substance, or how much stuff is inside of you. Your mass is how much stuff is inside of you, how much matter you're made up of. And you're not going to lose mass unless you lose what you're made of. So when you cut your hair, you'll lose mass. If you would lose weight, like because you lost water or you lost fat from your body, you lost mass. When you eat, every time you eat something because it's going inside of your body, you put on mass every single time because you put more matter inside of your body. Now, the SI base unit for mass is kilogram. And it's always going to be abbreviated at lower k, lowercase g. Kilogram, again, is the base unit for mass. Now, you're used to measuring mass, again, over here as customary units or English units. You're used to ounces and you're used to pounds. An ounce is about the weight of a slice of bread. And it's your smaller amounts there. Don't get this confused with your fluid ounces, though. This is ounces in like weight, what you would put on like your little kitchen scale at home. And pounds you're familiar with because this is how you measure your weight on a scale. When you step on a scale, it says you weigh 100 pounds. You're used to seeing pounds. When you go to the gym, you pick up a 45-pound dumbbell. And a pound is about the weight of a can of vegetables. Now think of a regular can of vegetables. The ones that are about 10 centimeters tall, when you grab them, they're about the size of your fist or the size of your hand is high. Not these like gigantic cans of beans or Bush's baked beans that you see that are like a foot tall or something. No, just a regular can. And a big thing would be to remember that there are 16 ounces in 1 pound. That's a useful conversion. Maybe we won't be using it much, but that's something to know in your life right now. Now, the abbreviation for ounces is OZ, and pounds is LBS. Now, what we're going to be using this year is the metric system. We're going to be using the metric system. So this is what we're using. We're using the metric units of mass, and they're going to be new, just like we're doing with the length. But the three of them are milligrams, grams, and kilograms. These are the three most common that you're going to see ever. Now, the weird thing is that down below, you see gram and kilogram. The gram is about the weight of a paperclip, so it's really not much. A gram is very tiny. A kilogram is about the weight of a thick book. Think like if you have a math textbook, that might be a kilogram, maybe a little over a kilogram. The math textbooks, or if you pick up a textbook here in class or in any of your classes, that would be about a kilogram. Think of it that way. Now, what you don't see is the milligram. And the reason that is a gram is already only the weight of a paperclip. It's so tiny. A milligram, let's just say 1 milligram equals, messed up my conversion. 1,000 milligrams equals 1 gram. So if you cut this paper clip here up into 1,000 pieces, that would equal 1 milligram. A milligram is really, 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 really tiny. That's the size of material that you get whenever you take pills. That's how tiny it is. You don't even really know it's there. It's so small. Now, some good things to remember is this. Kilo means 1,000. So a kilogram has 1,000 grams. So 1 kilogram has 1,000 grams. Again, 1 kilogram, 1 kilogram equals 1,000 grams. So again, metric, milligrams, grams, kilogram. English or customary, pounds and ounces. Now, the reason I have this is I just want you to see in your everyday life where you see the units of mass. Now, you're used to seeing, let's go English, this. Again, there's your ounces in the green here. I don't know what this substance is or what we have nutrition info on, but we have ounces. And there's your English. But after you see it that one time, when you look on most nutrition labels, all you see are grams and milligrams. I don't see any English units other than that one time. I'm just seeing metric after metric after metric after metric. So you do use the metric system in your everyday life. You just might not even realize it. I only see one English unit there, but the rest of these are all the pink ones. They're all metric units. So you use grams and milligrams a lot in your life. And I just wanted you to see that. So with measuring mass, and you will be doing that this year in class, you're going to use one of two things. Either a triple beam balance, which you used last year in Mr. Rosenberger's class, or an electronic scale that you would probably be using later this year. Both of these measure in grams. Both of these measure in grams. Remember that the abbreviation for grams is as lowercase g. That's going to be your abbreviation for the units grams. Now, an electronic scale I'm going to go over very briefly, but it's the easiest to use. All you're going to do is turn it on using this button. After you turn it on, if it does not say 0.00, you're going to hit the button again to zero it out. You're going to place the object on it, and then you're going to read whatever number it gives you. That's all you got to do with an electronic scale. It's pretty easy. The triple beam, here is some just very general rules. And I'm going to be giving you another video that has exactly how to read a triple beam balance. The important thing, though, when you're reading a triple beam balance, is every time you measure it, it's going to be in the unit grams, and it's going to have 2 decimal places in the answer, just like when you were reading a meter stick. Grams, 2 decimal places, okay? So these are just the parts of the triple beam balance. Please look over them, study them, so that when you come into class, you're able to easily identify them. So here we go with actually reading the triple beam. Now, when you want to read the triple beam, you want to add all of the masses together. What I mean by the masses, you want to add, here's your 100 gram beam. Here's your 10 gram beam. Here's your 1 gram beam. And whenever you want to get the total mass, you want to add them all up. So this first one here is 100. The second one is 50. And then down here we have what looks to be right on the 3. So you would have 100 grams plus 50. And this one here, this beam is always the hardest for people to read. The reason is they want to read it different than what they're used to, but it looks to me very, 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 very similar, if not the same as a meter stick. But instead of centimeters, these are grams, 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 grams. All of these are in grams now, and it only goes up to 10. But all of these are in grams when the meter stick was in centimeters. But you read the triple beam 1 gram beam the same way. This is 3 grams. This is 3.1, 3.2. I'll zoom in here so we can see. 3.3, 3.4, 3.5, 3.6, 3.7, 3.8, 3.9. And in between here is your guesstimate number. That's where you have to take a guess at it. So what we're going to do is read this the same way. And remember, just like with the meter stick. So we think this is dead on here. We think it's right above. We're going to say 3.00. So when we add these together, we get 100 grams plus 50 grams, plus 3.00 grams, and we get 153.00 grams. That's how you read the triple beam. Let's do another example. Sometimes you're going to have some of the beams that don't move at all. For example, this one moved to 100, but this one didn't go anywhere, so it stayed at 0. And again, I will have a video for moving the beams around later. So now we go to the 1 gram beam, which is always the hardest. Well, to me, it looks like it is slightly past that line. It looks like to me, even if we zoom in, that it goes slightly past that line. So because it's slightly past, you could say it is 0.90 grams and it's dead on. Yes, I would accept that here. To me, it looks like it goes slightly past, and because it goes slightly past, the same way we would read a meter stick, it's going to be 0.91, because this 1 here means it's slightly past the 0.9 mark. And it's 0.9, not 1.9, because it's before the 1. So your measurement, when you add them together, comes out to be 100.91 grams. Very important, don't forget your grams. One more example. The last one here, now we have 2 beams at 0 and just the 1 gram beam moved. So again, it's going to be 0 plus 0. And now we're going to read the 1 gram beam the same way we would a meter stick, but instead of centimeters, we're having it in grams again. So in this one here, I'm zooming in. Here is the mark, and it looks like that this triangle mark is slightly before the line. Because it's slightly before that 0.1 line, I'm saying it is 4.09. Could you say 4.08 grams? Yes, again, I would mark that correct. Remember, you get a little bit of playroom there. But when you add it together, 0 plus 0 plus 4.09, you get 4.09 grams. And remember, I'm reading this line here. I am reading this the same way I would a meter stick. It has not changed, so it shouldn't be too different from what you're already doing. So that's just measuring mass now. If you haven't, please use this to complete your notes. Please make sure that you complete your notes. And if you have any questions with this topic, please feel free to reach out to me. Thank you, everybody, and I hope you have a wonderful day.